I'm Mikoláš, but you can call me Mickey. I work for a company called Futured, and I will talk to you about scripting in LLDB. So I wanted to impress you with LLDB, but then I learned that I'm going after Cyril, and it might be a little bit difficult to impress you now. But I will do my best. So let's talk about why we care about LLDB, what is LLDB. Then I'll present the idea for the script, and then we will implement simple script for LLDB. So why care about LLDB? Well, let's talk about what LLDB can offer you. Simply said, LLDB allows you to perform tricks. And at the beginning, I prepared three little examples of what can be done in LLDB. And the trick number one is going to disappoint you. Sorry, but I felt the need to show you. It's called the PO command. And the PO command essentially does what? It just prints a variable to the screen. So here it is, a variable printed to the screen. And now the second trick. Thank you. Just referring back to Cyril, he did something which is really important for the presentation. He started copy-pasting things into the command prompt of the LLDB. And this is like the biggest recommendation I'm trying to convince you to do in this presentation. Just have a list of things and copy-paste them into the command prompt. And you can do something like this. I have an application, and the application contains a list of images. And I'm printing the contents of the whole application directory to the command line. So why I'm doing this? Well, maybe I want to use trick number 3. And trick number 3 allows me to bring files directly from the application directory to my Mac. And how I'm doing this? Well, the first thing is that I just copy-paste a comment into the LLDB, create an instance of data, and then use copy command, paste the reference to the data, and here it is, copied directly to my Mac. The copy command does not come with LLDB. It's in a separate repository from Facebook called Chisel. So this is trick number 3. And why I am talking about this? We have seen 3 tricks, PO command, expression command, print. And you can achieve same results without LLDB. You can do some prints in your code. You can download the application container, etc. But the big win when using LLDB is that each time you use a trick from LLDB, you will save some time. It might be a few seconds, it might be a few minutes, but the time saved adds up. And in course of a week, you might save a few hours, maybe. It really is about working efficiently. And so what are the upsides of LLDB? Well, saving time. And if you get used to work with LLDB, you can come up with your own tricks and shortcuts. You can perform some powerful tricks, and you can do it based on little bits and pieces of knowledge of internal working of Swift or your company's framework. And finally, if you are using UIKit, you should really start thinking about using LLDB, especially with the Facebook/Chisel repository. But here are some recommendations on what not to do. The worst experience with LLDB might be trying to learn new tricks in LLDB when solving an actual bug. You might especially easily spend some more time arguing with LLDB instead of solving the issue at hand. And this is from my own experience, and this will lead to frustration, and people will stop using LLDB. And so I will repeat it again. Prepare in advance. If you want to start using some new tricks, you need to prepare. You can have a file containing all your prepared commands. You can set up aliases, but do it in advance. And also, I would recommend you to get a LLDB cheat sheet from the internet. And understanding of the downsides of LLDB is also important. The LLDB might sometimes be completely broken, not have full support for a latest Swift feature, or it might complain about cryptic issues. And the important thing to do is stop. When you try some of your tricks you have tried a million times before and now it doesn't work, it might be a good time to stop and revisit it later, because you are probably not going to solve the problem. And avoid SwiftUI. In my opinion, you need to have a really deep understanding of SwiftUI, and even then, LLDB might not save you any time at all. So UIKit is good, SwiftUI is bad. And just remember, use LLDB to save time. And now we are going to dive into the technical topics. If you have never tried LLDB before, this might be a little bit too technical, but LLDB is software like any other, and I hope this overview will help you start building the confidence to use LLDB. So what is LLDB? LLDB is a program which is able to manipulate other programs. It attaches itself to that program and is able to pause its execution, reads its memory, and registers. It can also write into memory of the traced program, into read-only and executable memory, and it can write into registers and even into program counter. And it can load additional libraries and much more. Internally, the functionality of LLDB is divided into two components, LLDB and LLDB server. Those two components talk via protocol called GDB remote and can run on different machines. And again, you saw Cyril connecting to the LLDB as a server, which was an example of this. The LLDB uses API called ptrace to trace the process we are interested in. So how to interact with LLDB? Well, it's integrated into your Xcode user interface. We can use command line interface where we can execute individual commands. And there is an API for scripting, which we are going to discuss now. So the API for scripting is a little bit tricky. Here you have the LLDB, and the LLDB is wrapped in C++ API. And the C++ API is wrapped in Python API. This allows us to use Python to create scripts, but a little bit unusual API is the price we have to pay. And in this conference, you have already seen Kotlin, you have seen JavaScript, and now you will get Python. So one of the things missing, unfortunately, from the Python API is type hints, type annotations. So let us explore the basics of the LLDB API. The first class we will work with is called SBDebugger, and it represents the debugger itself. It can create so-called targets. We will discuss them momentarily. The most important command of the SBDebugger is handle command, which accepts string as a parameter and executes it as if you would paste it into the command line interface. The next type is SBTarget. Target represents a program running in the debugger. It allows us to inspect global variables, create breakpoints, explore symbols. It can launch process, load code files, or is used to attach to an existing process. Target is associated with process, but it may pre-exist any process. The SB process object represents a process running in your operating system. It has access to the memory of the process and allows you to read and write into the memory. It contains one or more threads. Each thread is represented by SB thread object. You can use the SB thread to do jumps, essentially write into the program counter, step around in the code, etc. As you would probably expect, each thread has its own stack. Individual functions in the stack are called frames. And there is a representation called SB frame. When we look for variables, we are doing so from a vantage point of a certain stack frame. This is also true for evaluating expressions. The SB frame allows us to read and write into registers, but registers are only valid for the topmost stack frame. And there is the last important type I would like to mention, and it's called SB value. It represents variables, registers, and results of expressions. And I would add a note to this. All the classes I have mentioned have a common problem. Objects returned to you may not be valid. So always check for validity of object before using them. You will save yourself a lot of headache. So now let's talk about the idea for the script. Firstly, I will show you a feature built into Xcode. It's called malloc stack logging, and it's accessible from Scheme Editor. In combination with Xcode memory graph, you can quickly learn where part of your code was created. Sorry, where an instance was created, not part of your code. Sorry. So I will launch a program. I will go to Scheme Editor, select malloc stack logging, launch the program, and after a while, I will go into memory graph. And here I can see an instance which is interesting to me, and I can see where the instance was created. So that's one useful trick. But this is especially, by the way, this is especially useful when working with UIKit, but today we will look at something different. We will look at backtracking closure creations. Escaping closures are reference types. This means that they are stored on the heap, and we should be able to use malloc stack logging. But there is a problem. Closures don't have type, so if you see them in the memory graph at all, they are marked only with words closure context. In the worst case, it's just malloc block. So what's closure? A simple closure looks like this. Notice that we capture self weakly. It will become important later. And now look how closure looks in memory. Closures are essentially a pair of pointers. The first pointer is a function pointer to the code of the closure, and the second pointer points at the capture context. Since closures can capture variables from surrounding code, it needs to be able to store them somewhere for later use. This somewhere is called capture list, and is often constructed implicitly. We store the list as the capture context. The context can be nil, but if it's not nil, it must be stored on the heap, and it must work with automatic reference counting. So we can use the context pointer to locate the creation of using the malloc stack logging. But out of the box, Xcode does not show the context pointer. It only shows the function pointer. So here is the idea for the script. Our aim is to teach LLDB how to print the context pointer. We are going to do so by reading two consecutive pointer-sized numbers from memory and print them. With that, we can use memory graph, and we can achieve our ultimate goal of backtracking closure creation. So let's do the scripting. As I said before, we are going to use Python. And the first thing is that I will show you how to set up proper development environment. And I'm going to use Visual Studio Code. The default extensions for working with Python are called Python and Pylons. And we want to use features like type checking and suggestions. And so we need to do some additional setup. We need to tell Python where to search for the LLDB API, which we'll do by placing this line of code into the shrc. Basically, Python path is an environment variable which tells Python where some modules may be. And then in the Visual Studio Code, we will go to the Pylons extension settings and set type checking to standard. And I will show you how it's done live. So the first thing is we are going to open the ZSHRC file. We have the property already there. We can open the settings, set the type checking mode, and then we are done. And we are going to create our first script and load it into LLDB. So I will open some random directory and create a file called first.py. And I'm going to import LLDB. And here you can already check whether your environment is set properly, because if you hover over the LLDB text, you should see the documentation. And the first thing we need to do is create a function with this specific name called LLDB init module, with 2 arguments. The first is debugger, the SB debugger type. And second is dictionary, containing dictionary from string to any, but we will need to import any type from Python typing module. And now we can just write hello world. And then we can launch LLDB and type script comment script import, which imports our script, copy the path, execute it, and we are done. So this was the first script we have created for LLDB. Now we have our environment set up, but before we go to the full script, I will just warn you that Python uses slightly different notation for generics. It uses square brackets. So now I will show you some code. It's only going to be 4 slides, so don't panic, please. We will start with some utility functions. When I create LLDB script, I like to implement set of utility functions first. I consider this approach to be more readable, and it's a convenient point to add type hints to your code, which is important for better orientation in more complex scripts. So what we see on the screen is a small utility function which reads memory. Remember, the memory API belongs to the SB process, so we provide it as a first argument. We also need to know what memory address and how many bytes we are going to read. And then we return optional bytes object. Bytes is built in Python type. Firstly, we initialize an empty SB error object into which read memory function will store any errors if it occurs. This is a common pattern in C++. And after we have everything ready, we can call read memory function and verify whether we are successful or not. But for our convenience, it's also useful to create a function which reads only 8 bytes from the memory and returns them as integers. It calls our read memory function, and the string argument little refers to the byte order in which the bytes are stored in the bytes type. So now that we can read memory, we can create a function for pretty printing Swift closures. We get an instance of SB process. We can pass it down to the memory reading functions and address where a closure should be located, and we use the read 8-byte functions to read 2 consecutive points from memory. We return formatted string from this function, which contains pointer we just read. Function nice hex format is my function, which makes hexadecimal strings from numbers. And now the most important function we have seen it. This function is called by LLDB. Whenever LLDB wants to format a value, we need to provide the specific arguments and return value. The SB value, sorry, the SB, yeah, I will start it again, sorry. The SB value instance refers to the variable we want to decorate. The string we return is the string which will be presented by LLDB, for example, in our user interface. First, we need to get a reference to the process so we can read memory. We can do it by asking each individual object to give us its owner. But remember, the API can return instances which are not valid. We always need to check for validity prior to making any call. I have shown only one example due to the space constraints. By calling getLoadAddress on the value, we can locate the value in the memory, where we should perform the memory reads. Then we will verify that the value, in fact, could be a valid closure by verifying the size of the value in bytes. We would expect that the closure would be 16 bytes long, but for some reason, the LLDB thinks that the closure is only 8 bytes long. With all the arguments prepared, we can call our pretty printing function. Lastly, we need to teach LLDB what types we want to format with our new formatter. Oh, I'm sorry. For this purpose, we will modify our init module, which runs whenever our script is loaded. And instead of printing hello, we will execute this command in the debugger, comment type summary add. We need to specify that formatting is done via Python function. The function is referred to as the name of the Python file appended with dot and the name of the function. But the most important thing is the last argument. We tell LLDB that we want our formatter applied to all types conforming to a provided regular expression. For better clarity, I have divided the regular expression using colors. Blue part specifies that we need the whole match. Yellow part represents the parenthesis and arrow, which indicates closure. The red part says that inside of the parentheses can occur any string of letters, spaces, dots, and commas. And now we are going to demonstrate how this works in practice. So you can see that I have all the functions from the slides. You can see shortly, you will be able to see the nice hex format, which I have not included into the slides. And then we will copy the path to our script and go into Xcode. And I will pause here just a little so you can so you can look at the slide, basically. And we are in a function which performs network call, parses the output from the endpoint, and returns a completion handler. This is pretty common pattern, and the completion closure is going to be the closure we are going to dump. So now let's look how the LLDB behaves by default. So we will use command frame variable closure, and yes. Completion, sorry. And you can see that there is only the function pointer. Now we are going to load our script. The script is loaded. And we are going to do it again. And now we can see that at the end of the output, there is our custom formatter. We can grab the pointer of the capture context, run memory graph, paste the address to the filter, and we can highlight the instance in the memory graph, and there we can see the backtrace of the creation call. So, but we are not done yet. We will create another breakpoint. We will continue the execution. And now you can see that even the right pane of Xcode is now using our custom formatter. So we can have this feature passively present all the time. And I would add with almost no additional overhead. So it's not like some wild thing that will slow down your Xcode. And we are done. So let's wrap up. I would recommend, if you are interested in this topic and you would want to dive into more detail, to look at a book called Advanced Apple Debugging and Reverse Engineering from Codeco. I'm not affiliated with them. I have used this book, and it was recently updated. And if you try to decide to use ChatGPT, I have done this too. And just be careful because it hallucinates a lot. But in most cases, if you have your development environment set up properly, you can catch the more obvious problems ChatGPT generates. I would also recommend again Facebook/Chisel, because it's a good resource of already created scripts. And for more ideas on what you can do with Swift, check out this runtime package, which contains a lot of interesting hacks into the Swift runtime. So to summarize, I have described basics of LLDB API, set up a proper environment, demonstrated real-life usage, and told you where to search for resources. But we didn't discuss expressions. It was by design, because it's even more interesting, and we don't have time for this. So, but if you want to see some interesting expressions, feel free to go to my repository of LLDB scripts and share your experiences with me. So thank you.
Thank you very much, Miko. We have good time for some questions. Yes, I have Nick over there.
Hi. That was a really interesting talk, thank you. Sorry, it's kind of more of a comment. I know everybody hates those, but you mentioned that PO is the print command in LLDB, and it's actually the print object command, and what it does is it prints the description of the object. So if it doesn't have a description, it sometimes doesn't give you useful information. And if you just use P on its own, that will do things like print the structure of a struct or like the pointer of an object, which is sometimes quite useful.
This is not true, actually.
No?
No, because you are correct, and you have probably seen LLDB beyond PO, which is outdated by now. A year ago, and I will do it. I have the time, so can you see it at least a little bit? I hope so. So I will execute LLDB. Hello? Can I do it bigger? No, I can't. Command plus? Oh. Where is plus? Oh, here. Nice. Thank you. And I will type help, PO. And as you can see, the PO is an abbreviation for dvim print. And dvim print is a new thing, like a year ago new, called do what I mean print. So initially, it will try to do the object description as the P command. And if it fails, from some reason, it falls back to the expression. So, but there was a second problem, and it was misunderstanding between us probably. When I referred to print, I meant like print in Swift. So traditionally, as I have done debugging before I've started to use LDB, I've used nslog. Then when I went to Swift, I have started using to print and recompiling the program all the time. This is what I meant by the print word. Sorry.
Yes, we have another question down there. Keep your hand up so that people can see you.
Hello.
Hi.
Is there any way to preload the scripts in Xcode?
Yes, it is, and I have slide for it. So in case I would not fill out my time, you can create a file called LLDB init. You can even create a file called LLDB init-xcode, which only applies to Xcode. And there you can type your command script imports, you can create aliases, and in case you don't want to have a long list of commands which you constantly copy-pasting into the LLDB, you can create aliases for this. Place them into the LLDB init file, and it will be always present.
Thanks.
Thank you.
Perfect question when you're prepared for it, right? We have a question up here. Who will get there first? Run.
Thank you. Hi. My question is kind of related with the first session. So we've seen there also some LLDB magic, and I wonder if if app developer stops supporting the old iOS version, and somehow we launch an iOS app on our Apple Silicon Mac. So my question, is it possible to attach, as we've seen in the first demo with LLDB, to the iOS app running on the Mac and do all that magic and reverse engineering?
Well, LLDB is always present. But if the question is whether you can reverse engineer app which does not belong to you?
No, I mean just, is it the same for using LLDB with app running on iOS device or simulator, or the same app running on Apple Silicon Mac natively?
I don't probably understand the question. So you can later reach me out, and I will try to answer it then.
Yeah. Thank you.
Cool. Do we have another question? There's one up here in the front.
Hello. So you've said that the Python API is just a wrapper around the C++ API. Does it mean that I can manipulate LLDB stuff with C++? Because for me, it would be much more convenient than Python, to be honest.
Yes, but I have originally played around with idea that I will just use C++. But few things discouraged me from doing so, and one of those things is that I don't actually know whether you can, so you would need to load the C++ module into the LLDB somehow. And I don't know whether this is possible in Xcode. So this would be like the biggest question for me.
I understand, but assuming I could somehow get it to work, then the API would allow me to do basically everything that the Python one does, right?
Yes.
All right.
This is my understanding.
All right, thank you.
You're welcome.
Thank you. More questions? The lights are blinding me. No? That's good. Thank you, Miko.
Thank you.